So in this series of videos, we have been discussing how to recreate a similar behavior that we see in event loop in JavaScript, and till now we have recreated like a very basic version of the main task queue, the micro task queue, and how the execution takes place. We saw that as well. In this video, we'll try to simulate the WebAPI behavior and how that might look, and just a simpler version of it. So yeah, let's get started. So what we do is let's have a function like we discussed. The WebAPI is something that JavaScript uses to delegate things to the time-consuming things to something else. Since it's a single-thread language, it cannot run multiple operations in parallel. So it would delegate something to WebAPIs, and the event loop will keep on running and stuff. So that's what. Then let's call it delegate to WebAPI. So every WebAPI delegation has like a time-consuming task. So that's a task, and it has a callback. So what happens is, since everything is callback based, so what happens is when after executing task, what happens necessarily is it says to the WebAPI that once you are done, just push the callback to whichever queue is relevant. So sometimes it pushes the callback to main queue, sometimes to the micro task queue. Anything works. So what we do is set timeout. We have set timeout, and then we execute the task. Set timeout is there just to simulate a time constraint or something, which is somewhat ironic because set timeout is handled by WebAPI itself, and we are calling this WebAPI, but that doesn't matter. We are just implementing it for the sake of understanding it well, right? So now what we have is this dot micro task queue dot push. We push the callback there, and that's all how it happens. Now another thing I wanted to do was just to clean this up a little bit. I don't want this running flag here. I just wanted to get it out of here for now. What I wanted is we could just directly shift this to somewhere else. Start execution. I was thinking of doing something like this. Let's say this dot main queue and this dot main queue dot length greater than 0, or this dot micro task queue, which is below here, micro task queue dot length equals to 0. So if there are items in the queue, then what we do is the main task queue takes priority over the micro task. Otherwise we move on to micro task. We copy this for later. We don't need this. What we do is if this dot main task queue, else the micro task part should go here. So micro task queue dot length greater than 0, it won't come here. This is for the main task queue, and let's paste it here, and let's copy this and paste it here itself. Cool. So that's a lot of copy pasting, but basically essentially what we're doing is we are just like checking if there are any items in both the queues, and until there are items, just keep on executing them. That's what. So main queue takes priority over micro task queue. So if there are items in main task queue, finish those first, and after that, let's say if there is something remaining in the micro task queue, clean them up. So this is sort of like happens in via CPU commands and stuff. So system commands and stuff. So it basically signals it to start consuming items from the queue. It signals it to stop, and so on. So from our perspective, we can do this to simply understand it. So like until the queue is cleared, it will keep on running. Once the queue is done, it will stop, right? So this is what we have here. Then what we can do is we don't need this. Let's say this is used in the last example to sort of demonstrate an edge case. Let's remove this as well. Let's do my event loop dot delegate to web. What was the name? Delegate to WebAPI. So I paste it here. So we have a function here, console.log. This is from WebAPI, and we print the index, and then we have the callback function here as well. So this is the callback function, console.log. This is the callback from WebAPI, and same, we kind of do this, and that's all. So we are basically delegating some tasks to the WebAPI, some time consuming task. Let's say this is some time consuming task, and we simulated that using this set timeout. We have delay of 10 for every task, and then after it's done, we push the callback to the macro task queue. The task can get pushed to the main task queue as well, depending on the nature of the task. But for our case, let's just push it to macro task queue. One thing that you would notice is here, once the first run goes through, this function will stop. So since there is no system command or anything as such to trigger the queue or jumpstart the queue once items are added, we'll do it manually here for now. So once we add something to the macro task queue, we'll tell that, okay, like for a notification sake of it, we'll just call the function from here as well. Like, okay, there are some functions in the macro task queue that you need to process, go ahead and do it. So that trigger point we do from here now. But ideally it should be some kind of an observable behavior, like that we should not have to tell it manually that do it now. It should know on its own. Like the queue thing should be independent of this, and it should process things independently. But for the sake of simplicity, we are just notifying it as well from our end. But this is not the responsibility of the WebAPI to notify it. The WebAPI's responsibility ends here, right? It ends here. Notify not related to WebAPI. So the WebAPI's responsibility ends here. The notification thing we are doing on our own, such that it processes the task in a macro task queue here for this case, right? But the responsibility of WebAPI is just to perform the task and push it to the callback. It's not like telling the event loop that, oh, okay, I pushed something, do it now. No, it's not the WebAPI's responsibility. That's something else. And yeah, let's see what happens. Now index. Whoops, I made some mistake somewhere. Start execution not defined. Oh, yep, that's what. So as you can see, so what happens is currently at this we get all of them. This is from WebAPI. After WebAPI we get the callback that was pushed there, then next the callback that was pushed there. Now to kind of have some weird behavior, let's increase the time a bit. We get the same thing, but now let's say what we do is maybe add some random delay. So this is where we would see the async behavior of it. Mat.random, we have this maybe in 2000 or something, I don't know, let's see. So here is the weird behavior that we get, right? So random time consuming task will take random amount of time, and that means those getting pushed to the macro task or the callbacks getting pushed to the queue will also happen in different amount, like different point of times. So as you can see, this time the fourth one happened first, and then the fourth the callback related to the fourth WebAPI got pushed to the queue, and that got executed. Then 3, then 1, then 7, and we can run it again. We'll get different results, and if we run it again, we get different results. So this is how we'll kind of, like, if you want to wrap the head around how JavaScript async works, this is like very similar to that. There are other nuances involved because of course we are not programming system level, so that's out of the scope for now. But this is a similar behavior that you can expect when you explain something like async behavior of JavaScript as such, right? So it delegates something to something else, it pushes it back to the queue, whatever is pushed, the queue executes it, stops there. Then again the next next WebAPI execution happens, it pushes it to the queue. When things are pushed to the queue, event loop pulls them out, executes them, they're done. So this is the callback, this is the callback, this is the callback. So this is the behavior that you would see in like many places. The one thing that's kind of different is the trigger point. Since we are triggering it on our own, this is not ideally an observable or independent behavior. Like a smart enough system would in itself know that there is something in the queue, and it will pull them out and execute without like this having to tell that okay, start execution now. But for the sake of simplicity, we kept it this way. We could have also have something like maybe run every 1000 seconds, keep polling if there is anything in the queue and executing. There are 1000 approaches that you can do this, but ideally it should be like it should get notified on its own via some observable mechanism or observable pattern. Like it gets notified, it executes, it shuts itself down so that CPU is released, and same happens back and forth. So which is ideally done by the system commands and all. So we are not going to that here. So yeah, I think that should be it for this video. If you found it helpful, drop a like, drop a comment, share it with your friends. We basically started with a very bare minimum example of the event loop. We then kind of shaped our head around it to build the intuition, and then we moved to the technical terms involved. We kind of correlated that situation with how really things work, and then we implemented the whole thing that we discussed, right, in a very bare minimum simple manner, which is enough for understanding things and figuring out its cases. So yeah, that should be it for this video, guys. If you liked it, okay, I already said that. My bad. Okay, see you folks, bye.